Hey everyone, welcome back to another video on kinematics. Today we're going to continue talking about the motion and the free fall. We're going to see how to use the algebraic uh, way of solving free fall motion examples. Yeah, last time we looked at it from the perspective of the graphs. Today we're going to talk about more about the algebra part of that, using equations of motion. That will help us understand the projectile motion more better. So, for example, we have a scenario over here where an object is thrown with some u upwards. It attains a maximum height above the ground, h, we do not know. And above this point a, it attains a height small h. And in time t, we need to figure out what's the maximum height small h. No, sorry, not this is the maximum height above the ground, but maximum height above the a, sorry. So max height h above a. We need to figure this out. We need to figure out the time it takes for object to attain h height, small h height above a. Then we also need to figure out max height above ground, which we have designated to be, let's call it B, ground level. And we need further two more things. Final velocity, VB, just before it hits the ground. It hits ground. And total time of flight. So we are going to use, first we're going to use just the these variables themselves, and then we will plug in some values also. So we need to find out expressions for these cases first. So first off, to find out the maximum height small h above a, what we would do, we know that 2as v squared minus u squared for the going upwards motion. Since we have a back and forth motion like going up and down, we will assign a positive direction to be upwards. That means upwards displacement, upwards velocity will be taken as positive. Now, since while the body is going upwards, the body is decelerating because the acceleration is pointed downwards, this will be the point where velocity briefly turns zero. We saw that in the previous video, right over here, where the velocity changes direction. So it turns briefly to zero. So going back, we're going to apply 0 over here, u squared remains as it is. But to deal with the minus sign over here, we designated acceleration to be minus g and h small height. So let's simplify this further and see how this goes. This simplifies to minus 2gh equals to u squared negative. The negative and the negative get cancelled, and h would be u squared over 2g. All right, just an expression. Now, time it takes for the object to attain the maximum height above a, that is also straightforward. Now we can just simply use v is equal to u plus at. A is minus g. We know final velocity at the maximum point is 0. U minus gt So this would become u is equal to gt, and then time for to attain h would be u over g. So maximum height above ground, h, would be, we designated this ground to AB would be 200 plus, or we can just simply just call it AB plus u squared over 2g. We're working with expressions right now, so before we give values onto that, we will just work on expressions. Final velocity VB just before it hits the ground. Okay, now over here, they are for the last two approaches. There are two things we can do. We know the maximum height now, so we can just do the motion, talk about the motion from the highest point to the lowest point. We can just uh, use that. So considering only downwards motion. So straight downwards, oh sorry, no. Oh, sorry. Straight downwards motion. We know the height was capital H this time. We know this to be this H. We just need the expression for H, nothing else. We know the initial velocity was 0 over here. Final velocity is what we need to figure out. So final velocity, so we can just use 2as v squared minus u squared. Since in this part of the motion, the object is starting from rest, u would be 0, and v squared would be 2. Since we are only considering one directional motion, so that we can say g and capital H. So v would be square root of 2gh, final velocity. We designated this to be vb, so let's call it v. Another way to do this is considering net displacement. So net displacement, we talked about it in the last video also. So this would be the net displacement in the negative direction, which is going to be minus AB. We use the value 200. Let's forget about it for a minute. So this is A, this is B. So net displacement would be in the opposite direction from A to B. So minus the distance between A and B. So when we do this, this would be, and then we would use same thing, 2as v squared minus u squared. U, we can now use the initial velocity we used from over here, u. This is our v. A, we can use minus g because we are going using up and down motion. So 2 minus g, net displacement this time, S would represent net displacement, would be minus AB, and v squared minus u squared. Using the values, you would see that we would actually get the same thing. We would always get the same thing. Let's see whether we get an equation like this also. So we designated AB. We can designate AB to be h minus u squared over 2g. So 2g h minus u squared over 2g equals to v squared minus u squared. So when you multiply, you get minus 2gh, and plus, because minus minus would cancel out, so 2g u squared over 2g equals to v squared minus u squared. Did we wait a second? Okay, so we had minus minus ab. Oh, sorry, right. We had a minus ab. So this would become minus, this would become plus. So this would become plus 2g minus minus, and this would become minus. Right, okay. So now you see 2g gets cancelled. So we are left with 2g capital H equals to minus u squared equals to v squared minus u squared. Notice that u squared gets cancelled, leaving us with v squared equals to 2gh, exactly what we had over here. Now, let's use values to cement this understanding. Let's copy paste this entire thing. Let's give these some values. Let's give it 60 meters per second. Let's give the height, AB 200 meters, and we need to rederive everything. We need to find out this height, we need to find out the time, and we need to find out the maximum height, and so on. So the only thing we'd have is AB is 200 meters, U is, let's say, 60 meters. So let's see how would we do that. So H, which is basically uh, this height, small h. So this would be, we can find this using 2as v squared minus u squared. U is 60 meters per second above. V over at this part is 0. So 0 minus 60 squared, and 2 minus 9.81 times by small h. So you would get 2 times by 9.81, 19.62 h, and 3600. So this cancels out. H would be 3600 divided by 19.62. So this would be 183.5 meters. Now, in what time it attains the small height h? So we can use V is equal to U plus AT, which would translate into V is equal to U minus GT, because A is A is basically G is downward, so A would be minus G basically. So V0 at the highest point, U was 60, and this is 9.81 T. So T would be U over GT, 60 over 9.81. So 60 divided by 9.81, that would be 6.11 or 6.12 seconds. Now, if this distance was, AB distance was 200, like we found, we set over here, we can find out the maximum height above the ground, capital H, max height above ground, that would be 200 plus 183.5. So this would be 383.5 meters. Now to find out the final velocity just before it hits the ground. So remember, we had two methods of doing that. We can use this height falling. At the maximum height, initial velocity is 0, final velocity we need to figure out. So we can use 2as v squared minus u squared. Oh, we did not use the time of flight. Okay, we will do this over here then. So final velocity, this would be 2. Because we are only considering downwards motion, so 9.81, 383.5 equals to v squared minus 0. So v would be 2 times by 9.81 times by 383.5. This would be 86.7 meters per second. Now we can find out the time of flight also. So the total time of flight from this to this. We can use the net displacement, which would be minus 200. Remember, we also use the net displacement concept over here. So we would get the same value, but let's use the net displacement concept over here. So S is equal to ut plus half a t squared. S is this time minus 200 because this is the negative displacement. Ut 60 times by t plus half upward motion positive. So this is going to be minus 9.81 t squared. So as you can see, this has become a quadratic equation. So, so minus 200. What we can do is we can multiply both sides by 2. So you will get 400 equals to 120t, minus 9.81 t squared. So taking everything on one side or just simply multiplying both sides by minus, you will get 9.81 t squared minus 120t minus 400 equal to 0. Now you can solve for this 9.81 x squared minus 120x minus 400 equals to 0. You would get two values. Let's use the normal mode. Right, okay. So one value of t is coming out to be negative, so obviously time cannot be negative. So it's 14.95 or roughly 15 seconds that we can count for. We can do it another way. Since we already found the time to attain the height small h, we can find out the time to drop from the maximum height also. So what we can do, time to drop from h. We can use wait a second. Okay. So we can use s is equal to, since the highest point u is 0, so we can use half a t squared or simply half gt squared. So this would be just the time to drop from the maximum height. So height it is falling is 383.5, 1/2 times by 9.81 times by t squared, which we will have to add from the previous time to attain this maximum height. 383.5 times by 2 divided by 9.81, and then we take the square root. So this is, we get 8.82. Oh, sorry, 8.842. This is this height, just to simply draw. But when we add the height to attain this, so total time would be, what was that was that time? 6.12 seconds plus 8.84, let's call it that. Oh, sorry. So 6.12 plus 8.84, this is 14.96, exactly what we had over here. Barring mistakes from rounding, this would be the total time. Let's call it capital T just to distinguish from the other times we have been calculating. Now, let's take this forward into projectile motion, because if we understand this, we can understand projectile motion much better. So, in projectile motion, what we have different scenarios, but what we have in common in all those scenarios is that we have velocity in some direction, and what we would need to do to solve this would be resolve the motion into two different directions. Sorry, this is uy, this is ux. So we have to solve motion in 2 dimensions to be able to solve the projectile motion questions. So we will get the same type of questions. What is the maximum height attained? What is the range covered? For example, what is the net displacement? Sorry, what is the time to achieve a displacement somewhat like this? Those type of questions that we will see. Same thing which we saw over here, but over here things are slightly different. How? Because one component of motion has acceleration, the other one doesn't. Since weight is only acting downwards, acceleration only acts downwards. So there will be an acceleration only downwards. What this will do is it will cause the vertical velocity, let's make it over here, the vertical velocity to have an acceleration component, but since there is no acceleration parallel to the horizontal direction or horizontal component, there will be no acceleration in that. So essentially what we are doing is we are separating projectile motion into vertical motion and horizontal motion. So let's talk about the vertical motion. So exactly same thing what we just talked about before. The equations would be the same. We don't have to do anything. Uy would be the initial vertical velocity. We can have a Vy somewhere along the way. It could be over here, it could be over here. We don't really care. We can designate Sy for the net displacement vertical, and acceleration y, vertical acceleration, and t. t anywhere for like any part of the motion. So we can reformat equations of motion in for vertical. So v is equal to u plus at becomes vy equals to uy plus ayt. S is equal to ut plus half at squared can become sy net displacement equals to uyt plus half ayt squared. We could also have s is equal to, no, sorry, 2as equals to v squared minus u squared. This would become 2ay sy vy squared minus uy. You could have the other one also with the average velocity. It doesn't change a thing. But since horizontal motion does not have acceleration, so let's show the things over here also. So sx, vx, ux, acceleration x, t is equal to same. So acceleration x is 0 and acceleration y is equal to g negative because we are taking upwards as positive. So ay minus g ax equal to 0. So if acceleration component is 0, v is equal to u plus at would transform into vx equals to ux because there is 0 acceleration. That means horizontal velocity remains the same. Similarly, if there is no acceleration component over here, this would just be x equals to uxt, constant velocity. Same thing over here. This would actually lead us to the same thing. So important point to notice over here, horizontal component of velocity remains constant and vertical component of velocity undergoes acceleration. So if we replace out the ay with minus g, so this would become, minus g, and minus g, right from over here. There's nothing more over here. We are just separating motion. So let's see example number 1, where the object returns to its same level. Same level, that means net displacement would be 0. So object returns to same level. That would mean net displacement is 0. So whatever values we have, that would become very simple. So this is your uy, this is your ux, this is somewhere over here vy, vx. We know acceleration is downward. So, for example, let's give some proper value over here because we know the equations now. So let's use some value. Let's say u is 60 meters per second and the angle is, let's say, 30 degrees. We need to find out the maximum height attained. We need to find out the total range, which is the horizontal distance attained. This is your R range. So let's find these out first. So, oh, and yes, the total time of flight also. You can find out the time for this part also, just like we did last time. So one by one. For maximum height in this, the time to achieve the maximum height, we just need vertical motion. So using vertical motion or vertical component of motion, we have Vy equals to Uy minus Gt to a, V squared minus Uy squared minus 2G, let's call it S. You can change it the other way around also. You can multiply the minus on both sides. We will have Sy equals to Uyt minus half G T squared. So one by one. So at maximum height, we can use that. So at maximum height, just like in the vertical motion, Vy would become 0. So when Vy becomes 0, Uy minus Gt would remain, and then T would become Uy over G. So now we can use the values. This would be 60 sine of 30, 60 sine of 30 divided by 9.81. 60 sine 30 is basically would be just 30 because sine 30 is half. 30 divided by 9.81, this would be 3.058 seconds. We can find out the height without using the time. We can find out the height also, but we can use the time component also. But let's say we don't want it. We can use this thing. So Vy, we know it's 0. Uy is 60 sine 30 degrees squared minus 2 times by 9.81 times by height. So minus cancels out. So 60 sine 30 is again 30. So 30 squared divided by 2 divided by 9.81. Sorry, we get 45.871. You could use this equation using the time that we found over here, and we would get the same thing. Now, the range, total time basically, So for the total time of flight, in this case, we have to remember that the net displacement becomes 0. So we will use Sy ut minus half gt squared, but replace out 0 equals to 60 sine 30 times by capital T just for total time of flight, minus half 9.81 T squared. So multiply 2 on both sides, you will get 0 equals to, this is 30, so 30 times by 2 would be 60, minus 9.81 T squared. This gives us a quadratic equation, but it's easily factorizable. So we can bring t outside. So one answer is t because it's obvious. At time t is equal to 0, it would be at that point. And the other would be 60 divided by 9.81. So this would be 60 divided by 9.81, 6.116 seconds. Notice one thing. This is 60 and this one was, where did we go? 30 divided by that. So this was 30. And this is not a coincidence. This is exactly how this happens. So if you had the total time of flight expression, it would be 2uy over g. You can, as an exercise, you can try that. It would come out the same. So if it's coming back to the same point, same level, same displacement, net displacement, if it is become 0, the total time of flight would be double the time it took to achieve that maximum height. Now that we know the maximum height, we can find out the horizontal range, r. So Sx equals to uxt. That would lead us to r. Since ux remains the same, so 60 cos of 30, and this capital T, 6.11 seconds. So what formula we used? R ux t. So 60 cos 30 times by 6.116, we get 318 meters. Now this was the case when it's returning to the same level. But what if it continues going? Case 2. Let's say it's thrown, let's say this way. This is the ground. We would have to do the exact same thing we did before. So if, let's say, this difference is height, 200 meters, and let's say we use the same values as before. So this is 60 degrees, this is, let's say, 30 degrees. So we would have 60 sine 30, 60 cos 30. And we need to find out the range this time. Let's say we want to find out the range and the total time of flight. So range and t are what we need to figure out. We can also we can also endeavor to find out the maximum height. So we would repeat some similar process that we did. So vertical motion would be similar. For we need to figure out what this height, small height, is. So this would be sy uy. Oh, we don't know the time, right? So what we can do is 2as v squared minus us. Transform it into vertical motion, 2 minus g times by h equals to v vertical velocity would be 0 at this point. So at this point, vertical velocity would be 0, minus u squared would be 60 sine 30 squared. 60 sine 30 is 30. So let's simplify that. This would be 2 times by 9.81 times by height, minus 30 squared would be 900 minus. So minus minus cancelled. So h would be 900 divided by 2 divided by 9.81. 45.87 meters. So max height h would be 200 plus 45.87. This would be 245.87 meters. Whether you round it to three significant figures or not, that's right now we are not focusing. Now, the range. First, let's do the time of flight, because if we know the time of flight, we can figure that out. So total time t of flight. So what do? We use s is equal to ut plus half at squared. So transform it into vertical motion, uyt plus minus half gt squared. So negative displacement, so net displacement is minus 200 because vertical displacement is minus 200. 60 sine 30 is your initial vertical velocity, and this is half 9.81 t squared. So multiplying 2 on both sides, this becomes minus 400. This becomes 30 times by 2, 60 t. This becomes 9.81 t squared. Didn't we get the same thing over here? Oh no, on this this one. Oh no, okay, all right, never mind. Okay, so this is a quadratic equation. This becomes 9.8181 t squared minus 60t minus 400 400 equals to 0. So we solve this quadratic equation. 9.81 x squared minus 60x minus 400 equal to 0. You get one answer would be negative. Obviously, time cannot be negative. So this is 10.138 seconds. So this is the total time. So now we can find out the range. This would be ux times by t. So 60 cos of 30 times by 10.138. So 10.138 times by 60 cos of 30. This would be so this is coming out to be 500 and let's say 27 meters. Now that's enough for examples like this. Let's try some past paper questions to do this. We saw some of these questions in the previous video, so this video will focus on the free fall and projectile. So an object is projected from horizontal ground at a velocity of magnitude u, an angle theta to the horizontal. It hits the ground at a time t after it is projected. That means somewhere over here. Assume A resistance is negligible. Which statement does not describe the motion of this object? Horizontal component of the object's velocity is constant and has the value u cos theta. That is correct because horizontal velocity would be u cos theta and vertical component of the velocity would be u sine theta, and the vertical velocity will undergo acceleration also. Horizontal distance traveled by the object is this. That is also correct. The time taken for the object to reach maximum height is t1/2. That is also correct because that's the half time. We saw it in the example where it lands at the same level. Vertical component of the object's velocity is constant and has the value u sine theta. So initial velocity does have u sine theta, but after that it would have u sine theta minus gt because of the acceleration. So this is the only thing that's not correct. So let's carry on. Right. A boy throws a stone with a horizontal velocity of 10 meters per second from the top of the building. The height of the building is 8 meters. The stone travels along a curved path until it hits the horizontal ground. Air resistance is negligible. How long does it take for the stone to reach the ground? Okay, so one thing you have to notice, initial vertical velocity over here is 0 because it's thrown with horizontal initial velocity. While under this motion, it will develop and gain velocity due to the acceleration. We know the negative net displacement that it will have, so Sy equals to uyt plus half gt squared, because we only need to worry about like the downwards motion, so we can just say half gt squared. So Sy is 8, u this becomes 0, half 9.81, and t, did they, oh no, we actually need to find that. So this would be square root of 16. That means t squared is 2 times by 8 divided by 9.81. So 16 divided by 9.81, you get 1.277, which is C. Now let's move on. The diagram shows the path of a golf ball. Which row describes changes in the horizontal and vertical components of the golf ball's velocity when air resistance is ignored? Horizontal velocity remains constant. So horizontal remains constant, but vertical velocity undergoes uh, change due to acceleration. So this would be minus half gt. So what am I doing? Minus gt. Simple. So constant velocity, that we can cancel out these because horizontal is constant. Vertical, constant acceleration downwards. This is the only thing that's correct because vertical acceleration downwards, a is equal to minus g, which we do that because we take upwards as positive. It's constant. Acceleration is not changing. So C would be the correct answer. Right. Okay. A projectile is launched at an angle of 25 degrees to the horizontal. So this is the angle 25 degrees with the horizontal component of velocity of 13 meters per second. So basically the u cos 25 degrees is 13 degrees, 30 meters per second. What is the vertical component of the velocity of the projectile when it is launched? So when we find out u, we can find out the u sine 25 also. So u sine 25 is what we need to find out. U we can just rearrange from this 13 over cos 25 times by sine 25. And notice sine over cos becomes tan. So this would become 13 tan 25. So 13 tan 25. 6.06. So this would be B part. Right. Okay. Projectile is fired from point P with velocity v at an angle theta to the horizontal. It lands at point Q, a horizontal distance r from P after time capital T. the acceleration of free fall is g, air resistance is negligible. Which is equation is correct? So for r, we know we made that basically equation. T is the time of flight and ux is the horizontal velocity, which remains the same. So v cos theta times by t. So vt cos theta, that would be the correct answer. Right. An astronaut on the moon, where there is no air resistance, throws a ball. Ball's initial velocity has a vertical component of 8 meters per second and a horizontal component of 4 meters per second. The acceleration of free fall on the moon is this. What is the speed of the ball 9 seconds after being thrown? So speed means we need to find the magnitude of the total velocity, not that. So Vx will remain as ux because horizontal velocity is not changing. But we do need to find Vy after 9 seconds. So Vy initial velocity is this, u minus gt, the uy. So this is 8 minus g is, sorry, this time we will use the acceleration due to free fall, 1.62 times by 9. So this would be 8 minus 1.62 times by 9 minus 6.58. That means the velocity would be acting downwards. So speed, the magnitude, would be Vx squared, Vy squared. This can also be squared. So 6.5, sorry, Vx was 4 squared. Vy is 6.58 squared. So square root of 16 plus 6.58 squared, this would be 7.7. This would be the correct answer. Right, I think we can, okay, let's do one more. A ball is kicked so that it has initial velocity of 12 meters per second at an angle of 50 degrees to the horizontal ground. Assume that air resistance is negligible. What is the maximum height above the ground that is reached by the ball? So basically, remember, for the vertical maximum height, we just need to remember that at the maximum height, Vy is 0. So there is no time requirement. So 2as v squared minus u squared we will use. 2a is minus g. H is what we need to find out. Vy would be 0. And uy is given as 12 sine 50. So 12 sine 50 whole square. So h would be 12 sine 50 whole squared divided by 2g, that is 2 times by 9.81. So 12 sine 50 whole squared divided by 2 times by 9.81. 4.3, this would be C. All right, let's try some paper 2 questions also. Let's see some. Okay, define acceleration. We know it's rate of change of velocity. Although this is the minimum requirement, but you could add the with respect to time. So with respect to time, this does not take away the meaning from it, but it just means that the ratio that we are talking about in the word rate, it's with time. A small aircraft is flying horizontally at a speed of 42 meters per second at a height of 63 meters above horizontal ground. So it's flying horizontally, meaning it has no vertical velocity. Aircraft drops a small parcel. Parcel is released from the aircraft at the instant shown. On figure 1.1, draw a line to show the path of the parcel as it falls to the aircraft to the ground. Okay, so initial velocity is this. So it will fall this way. It will fall this way because it's going to gain vertical velocity as it moves forward. Calculate the time taken from the instant of the release to the instant the parcel reaches the ground. So we have the net displacement over here, so Sy, Uyt, plus we can use half gt squared. This is going to be 0 because initial velocity vertical would be 0. So 63 half 9.81 times by t 0. So t squared would be 2 times by 63 divided by 9.81. So t would be the square root of 2 times by 63 divided by, square root of 2 times by 63 divided by 9.81. This is 3.58. Two significant figures, this would be 3.6. This is where you will actually write the working, but I was writing it that way. Calculate the vertical component of the velocity of the parcel immediately before it reaches the ground. So we have the time, we can actually find the velocity. So Vy equals to Uy plus gt, because we are considering the vertical downward motion, so we can do that. Uy again is 0, so this is just gt. 9.81 times by 3.583. While calculation, use the values with higher precision, that means more decimal places. So this times by 9.81, 35.157, so this you can write it as 35. Determine the speed at which the parcel reaches the ground. Again, speed means the total magnitude of the velocity. So this would be the Vx squared plus Vy squared. We have already found the Vy squared. Vx was 42. So 42 squared plus 35 squared. So this squared, answer squared plus 42 squared. This would be 54.772. This would be roughly 55. Okay, let's move on. Right. Define velocity, rate of change of displacement. So rate of change of displacement. A student throws a ball over a vertical wall of height h as shown. The ball leaves the hand of the student at a height of 1.2 meters above the ground, so it's already 1.2 meters above. The ball has an initial velocity of 22 meters per second at an angle of 40 degrees to the horizontal. The wall is a horizontal distance of 36 meters from where the student releases the ball. Determine the time taken for the ball to reach the wall. Right, okay, so what we can do is you can use the range over here. So we need the horizontal distance, Sx equals to Ux t. So, right, Sx we know to be 36, Ux is 22 cos 45. Sorry, 40 degrees. So 36 divided by 22 cos 40 degrees. So this would be 2.136. You can round it to 2.1. Calculate the vertical component u of the initial velocity of the ball. That was simple. That was just 22 sine 40 degrees. So 22 sine 40. This is 14.14, so 14 basically. The ball just goes over the wall. That means it barely covers this thing, this height This would be the net displacement at this point. Calculate the height h of the wall. Okay, so we know the time when it basically makes it over the wall. We can find out the net displacement at this point, at this time, and then we can add it on the edge. On the, sorry, 1.2. 1.2. So we just need to find out the SY, vertical displacement at t equals to, what was it? 2.1 seconds. So SY UYT plus, sorry, minus half GT squared. So this would be 22 sine 40. We have already figured out to be this to be 14. You can use the exact value to 22 sine 40 also. This would be better, but that's not a very big deal. Actually, you could use 14.14 also, times by 2.136 minus half 9.81 times by 2.136 squared. So this times by 2.136 plus 9.81 divided by 2, divided by 2 times by 2.136 squared. This is 52.585 meters. So h would be 1.2 meters above that. Wait, is this correct? Oh, sorry, this was supposed to be minus 7.8, sorry. So 7.826, so 1.2 plus 7.826. Right, okay. So 1.2 plus 7.83, this would be 9.03, so 9.0 meters. You can add 9.03 also, it doesn't change a thing. Right. Okay, let's see this. Define acceleration, that is rate of change of velocity. An Olympic diver stands on a platform above a pool of water, as shown. When the diver is on the platform, his center of gravity is at a vertical height of 9 meters above the surface of the water. The diver jumps on from the platform with a velocity of 5.9 meters per second at an angle of 60 degrees to the horizon. Air resistance is negligible. When the diver hits the surface of the water, his center of gravity is at a vertical height of 1.2 meters above the surface of the water. Calculate the speed of the diver at the instant he hits the surface of the water. Okay. So basically, we need to figure out what's the displacement, the center of gravity covered. So center of gravity covered, basically 9 minus 1.2. 7.8 meters. So center of gravity, since we are actually doing the center of gravity, so center of gravity actually covered 7.8 meters. So, right. SY, do we know the time? Wait, sorry, did they give speed of the water? Okay, so 2as v squared minus u squared, so you can use y. So vy squared, 2 times by minus 9.81. Net displacement is minus 7.8 plus the u squared is 5.9 sine of 60 whole square. So this would be 2 times by 9.81 times by 7.8 plus 5.9 sine of 60. Let's add brackets squared. So this would be 179.1435. So Vy would be actually we just need that, right? Because we need this. So Vy squared plus Vx squared. So 179.1435 plus Vx would be 5.9 cos of 60 whole square. Cos of 60 is divided by 2 basically, so this is going to be square. So this answer plus 5.9 cos of 60 whole squared. This is coming out to be 13.7. So basically you could say 40. Right. This is straight vertical motion. Right. A steel ball is projected horizontally from the top of a table. A ball is projected horizontally at a speed of 4.9 meters per second. The ball lands on the ground at a horizontal distance of 180 centimeters from the edge of a table. Assume that the air resistance is negligible. Calculate the time taken for the ball to reach the ground. Right, so we know the range now, so we can do Sx uxt. So t would be Sx is 180 centimeter, which is 1.8 meters, divided by 4.9 because horizontal velocity does not change. So 18 divided by 49 because decimal cancels out. 0.367. So 0.37 would be the answer. Calculate the vertical component of velocity as it hits the ground. So initially the uy is 0 and it gains speed due to acceleration. So Vy uy plus gt, because if we just consider the downwards motion we can add a plus instead of minus. So Vy would be uy is 0 plus 9.81 times by 0.37. So this times by 9.81, we get 3.603. So 3.6. Determine the magnitude and angle to the horizontal of the velocity of the ball as it hits the ground. Okay, so we need to know two things over here. We know that the horizontal velocity was, what was it? 4.9. Sorry, actually, this went this way. So this is 4.9 as it is. And vertical velocity we found out to be 3.6. So magnitude of the velocity we will find from Pythagoras theorem and the angle from tan. So magnitude would be sum of squares whole under root. So 4.9 squared plus 3.6 squared. This is going to be 6.8, so 6.08 or 6. 1, you can say, and the angle, this angle would be coming from tan, so tan inverse of 3.6 divided by 4.9. So tan inverse of 3.6 divided by 4.9, 36. 36.3 degrees, so roughly about 36. So this would be 6.1 and 36 degrees. Right, so I think that's more than enough. This video has gone on very long. Hopefully, in the next video, we will see the last thing that we left out in the kinematics topic, which is the experiment to determine acceleration due to gravity. And then that would be it for that topic. All right, so see you in the next video. Bye-bye.